glitch shaders can be difficult to render correctly, mostly due to the fact that you are breaking your mesh with vertex displacement, and also because it's not that easy to make it consistent across different mesh shapes or different camera angles. So I'm going to break down this full shader I did, and hopefully it will help you to fix all of these issues. We can start by simply importing a mesh. So we'll use a cube with some edges just to get nice vertex displacement. If you don't have enough vertices, then it can be an issue. I will also add tessellation in next steps, but feel free to adjust depending on the mesh you are using. Now we just need to create a new shader. Since I'm using HDRP, I'm going for HD, and then we need to use unlit model, just because we don't want our effect to be affected by light. So now in the shader, we need to tick off some of the options. So starting with cast shadows, we don't want that. So we set the surface type as transparent. Also, the render type, you can set it at transparent. And I guess that's all for the rest of the option. We can let it as it is. I'm also going to add some tessellation. Obviously, it's just for the demonstration. Do that only if your performance allow that. And now we should be ready to start. So we can start creating the material already and setting up on the cube. As you can see, because it's unlit, it's not affected by light anymore. So that's exactly what we want. And let's start with first texture. So this texture, let me show you. So it has one mask in each channel, basically. The red channel will be the main glitch effect. So it's basically just a strip, but feel free to experiment a bit and try different patterns. Next, the green channel will be the pulse effect that will be brought to top. And lastly, we'll have the blue channel with the regular strip that will be the hologram effect, basically. Now let's come back on our shader and add a screen position node. That will be the UV for the mask. So we obviously need to isolate the X and Y axis with a component mask. And we can connect it directly in the texture. We'll also need a panner, obviously, because we want it to pan. And let's add a scale and offset just to have some parameters. Now, we'll also need a time just for the panner. And I reduce a bit the scale, so the multiplier will be less intense. So this is basically the same as using time parameters, but regular time node gives us a bit more freedom. And now we can just set the speed at -0.5 on the y-axis. We can see the texture panning already, but let's see what happens when connecting that to the color. So I need to reset the material to be able to see the texture. Oh, and I'm also going to set back the inspector to the amplify one, just because I'm more used to. And now we can see our strip panning bot to top. So this is basically the base behavior that we want to give to the shader. Also, not that I'm turning off sRGB in the mask texture, just because we are using them in mask stored in different channel and not as an image. So now we can start duplicating the panner stuff we just did, and we are going to make a second one that will be a reference to our texture sample. So no need to create a new sample, just a reference. And that will be our secondary glitch. Let's just rename the texture mask map, for example. And because the map is not supposed to be changed across the different meshes, we just need to hide some of the features in the inspector. It will just keep the shader a bit more cleaner. Now we can plug the second one, and we'll addition them. So we'll be able to see a bit the variation with the secondary noise. Not noise glitch, sorry. And now we can see the two strips. Now the next step, and this is one of the most important for the glitch effect, will be to simulate some kind of randomness with some switches. So I'm going to show you a technique to generate some switches, and we are going to do some. So start with a scene time. It will be basically a sinusoidal curve, and instead of having a smooth curve, we want to achieve a kind of an instant effect, like transition between off and on. And we can do that with a fract. So let's see, for example, with a relay. So with a relay, you can preview the scene time, and you can compare it with the fract. So this is a bit more instant because it cuts the lower value, but we'll step it at 0.5. So we are sure that it's really going instantly from 0 to 1. So this is perfectly the kind of behavior that we want to achieve. We'll now make a second step, and we'll do the same thing with a multiplier, basically. So we'll add a multiplier after the fract, and we'll have the same thing, but with a variation. And now we'll just store that in two local variables. We'll call them random switch 1 and 2. And now we'll just have to use them as mask. So we are going to plug this into a loop, and it will act like a flip-flop between the two values. And that will be the scale for banners. I mean, for our UVs. So for the moment, just copy my values, because even if you'll be free to change them, because the UV are going to change later on, it will probably change a bit the behavior. So these values fit me for the moment. No, I'm just duplicating that and doing the same with other values for the second glitch. We plug that, and as you can see, it will act like a flickering a bit. So this is perfectly the kind of behavior that we are aiming for. So now let's have a look at the scene view. So right now I'm looking at the front view, and it's all fine. Just because we are using a screen position UV, the top one is also good. Like every angle looks fine. But now if I zoom in or out, as you can see, the scaling is obviously like the same based on the screen. So it's not the same based on the mesh. And that's a problem. So we'll fix that later. But right now we are going to add a bit more variation and glitch behavior. So right now we just did some switches, and we are going to do more complex glitches now. So it will be a bit more complex than just some flip-flop. So let's start with few times. I'm adding like 4 times, and each one of them will have different scale value. It's better than using a scene time, just because we are a bit more free with the scale. So same thing, I'm just duplicating them. And I'll be using some value I just tried on my own. You can obviously try your own values and just find the behavior that fits you. But for now, I'm just using these ones. And right now, we just need to multiply them basically. So we multiply them all. Then we'll just add a property float, and that will be a multiplier. So we'll use this to adjust the intensity of the multiplier. So as you can see, if I set like a really huge value, it's doing something else. So let's stick with 3, and we'll add a fract. This is already starting to look like the thing that we are aiming for, but we'll add a step too. And right now, we'll just step that to 0.9. Basically, it's acting a bit like a threshold. So at a value of 0.9, it will be harder to go on 0 value. So it will be occurring just more often. And at the opposite, if you go for 0.1, it will be occurring less often. Now we can save this in a variable. And this will be our small glitch response. So we come back a bit later on this, and we are going to do the big glitches now. So we can start with Vertex Position node. And we'll just step the y-axis with a value of 0.1 just to divide the mesh with a mask. And instead of using a constant value, we can use a scene time node and remap this with a multiply. And what we want to have is something that is moving. So when the spawn mask will occur, then the step will be at different values. So it will just add a bit more variation. Since we are not using real randomness, all the variation we can put in is good to take. We just need to use this in time to generate the big glitch mask, I mean the spawn mask, and this is the exact same way as we did before. So we just use a fract. We put a higher intensity with a multiply, and we just have to step this. Keep in mind that you need to use different value across the different spawner. So otherwise they will just be the same and everything will spawn at the same time, and that's not what we want. And here we go. We have our spawner, and we can just save it as big glitch spawn. Okay, so now we are going to come back on the big glitch itself, and starting with 2 multiply and 1 lerp node. The lerp will be handling the intensity of the glitches. So we are plugging this and this into alpha. And I'll be using 1 negative and 1 positive value. And it's important because we want the glitch to be able to go on the left and on the right, basically. Like otherwise, it will be always glitching in the same direction. So that's not really what we want. And we are using the mask directly in the multiplies. So the value are not really high just because it has to be really subtle. Same thing here. And as you can see, one has the intensity scaled for the glitch displacement, and one has not that. And that's because we want to keep it as a mask. So the first one will be the glitch itself, and the second one will be the big glitch mask. Right now, we can push it a bit and come back at the texture. And we're going to use the mask we just did. So we can just call two first switches that we did, and we're going to spawn some glitches. So right now we'll be using only the first one, and the first texture will be the negative value, and the second one will be a positive value. Now the spawn will be just a flip-flop between two different intensity. So this is exactly the same as we did before. So as I said, we negate this one and we multiply this with the glitch from the texture. So the air channel. So this one will be the negative one. So the glitch will go on the left, and the second texture will push the glitch on the right. So you can use a lot of different setup in this. You can use only one texture. You can also play a bit more with the values. So feel free to play a bit with it. Now we just spawn a second multiply and we do the same. So this one is not negated, so this is the positive one. So basically, the displacement value will be the same between the two texture. The only thing that will change is the position, just because they have different panning values. So we can lab them, and we'll use the second one for this one, and it will just swap between pushing backward or forward. I mean left or right, depends on how you see this. But it will alternate between negative and positive. To be sure that you understand it, I'm just plugging in some colors just to act like a debug, and let's see what happens. So let's say that the green one is the negative one and the red one is the positive. So as you can see, it will just spawn some positive and negative values randomly. Not really randomly, but it will look like random. Now exactly like we did for the big glitches, the small one will have their own mask. Basically one that is not going through the lab that is handling the intensity. So it will be a pure white mask, black and white mask, I mean. So we can do that by doing the exact same thing as before, but just using a lab directly between the two instead of going through an intensity lab. Now we'll just multiply that with the small glitches spawn. So this will be just to avoid the glitches to be always on the screen. Because right now the random switches are just for swapping between negative and positive, but we have no mask for the spawn or despawn. So this will be our small glitches mask. And in the same way, we are going to do the same with the glitches with the intensity. And we are going to save this into the actual small glitches. All right. And so now we have small glitches, big glitches, and we'll just have to combine them basically. So we just get the two glitches, small one and big one, and we just add them. Sorry, yeah, and add. And we'll just call that combined glitches. All right, so I just cleaned that a bit, and let's see what we got and the issues that we are facing. So let's use combined glitches with a step just to use it as a debug and see what happens. So right now it's looking good. This is the behavior that we want. But exactly as we mentioned before, the problem will be the zoom in and zoom out. Like we need to fix the screen UVs because we need it to be consistent. So let's do that. To be sure that everyone understands how screen UV work, let's see how it looks in game. Basically, if you plug the UV in the color output, we'll be able to preview where we are on the screen UV map directly in the scene. So U and V axes are stored in red and green channel. It will go from 0 to 1 values, which will be black to red or green. The addition of these two values will blend it to yellow, so that's what we have in the right corner, the top right corner, I mean. So this is not exactly what we want. We want it to be facing the camera view direction, but not really to fit exactly the screen UV. So right now you can delete the screen position and we are going to calculate the fixed screen UV position. So let's start with Vertex Position node, since it has to be relative to the mesh position. Now we are choosing Object to Clippers node, and we are passing that through Compute Screen Position to work. So we'll also need to normalize the Compute Screen Position directly, and then if we multiply this with a value, it will be basically the tiling of the UV. So we are just going to add a float, and this will be a property too. I set the type to 0.75 for now. And we'll do the exact same thing, but instead of using a vertex position node, we'll use a simple vector tree with value of 0. So this is a duplicate of what we did before, and also multiply. And then we just need to subtract these two values. So this is basically the basic to calculate that. And then we have to put that in relation with the camera, obviously. So we are doing a wall space camera pose node, and we'll subtract that with an object to world node. Then we are just doing a distance of this output. And we plug that into a multiply after the the subtract. So right now it could work, but I'm going to fix some issues that we can face with that, so it will be more correct. So let's split it and append into a new vector 4. And we'll do a multiply for the x vector. And we'll multiply that with the ratio of the screen. So we'll use the screen param node and we'll divide the dimensions. And we just need to plug that into the multiply now and connect it back to the vector. And we can save that as the fixed screen UV. Now we'll use it in the UVF4 mask. And here it is. We just fixed the UV now. And we can preview this. And you'll see that now the scale is fixed. So this will act a bit like a billboard. So as you can see, no, it's not scaling anymore. And the screen space position is still effective. So on top view, it will be still correct. Let's just compare back with the previous screen position node. So we can see the difference. As you can see, the scale behavior is really different. So let's stick back to the fixed one. And you can see that it's correct now. And back to the shader, you can unplug that now. While we are working on UVs, we are going to clean that up a bit and do other work with the UVs that we will need. And we are going to start with some wall position UVs, like custom ones. So let's start with a wall position node. And we'll add some controls for it, like panners and scale, etc. Let's start with the panner. So we can use a time node. So we'll scale it down a bit just to avoid really low values on the panner speed. It will be a bit easier to work with. So we multiply this with the panner property, which will be the speed actually. And we'll just duplicate that for the second one. Then to make it as a panner, we just need to just isolate the X and Z axis of the wall position and addition that with the result of the multiplication that we just did. So let's add the first one and the second one. Then we'll need to work on the scale and tile of the UVs. So we'll do 2 vector 4 for each, and X and Y will be the tile and Z and W will be the scale. So let's just name that so it's clear. And we can just duplicate that basically. So we'll use some values that I already tested. So firstly, we'll combine these 4 vectors too. We'll multiply the first one, the tile one, with the result of the add. So that will be the tile. And we'll just need to divide it by the scale. And here it is. We can save this as our first UV. So UV1. And we can do the exact same thing for the second one that we will call UV2. So we multiply the tile and we divide the scale. And here it is. We have our 2 world position UVs. We can clean this up a bit. And we'll use this 2 output to make our distortion effect. And that will be really easy. We just need our distortion texture. So for me, it will be basically a water normal. So depending on the type of normal, it will render a bit differently. I call this distortion map or distortion normal. And since I just want to keep it constant, I'll just hide it in the inspector. And we call back the 2 UV you just did. So first one is going into the first texture, and we'll just reference the normal to use with the second UV. So this one is the UV2. And now we just need to blend the two. So we need a lab for that and a property for the alpha. So it will be a simple float, and it will blend the two with each other. You could also play with different speed for the UVs because right now we are using only one float for the panels. So feel free to experiment a bit, and you'll be able to achieve different effects with that. And we can save this as a distortion variable. So we'll be able to call that at any time. To visualize the blend, let's just plug that. And the distortion output is in the color now, so we can see the normal map. And now, as you can see, playing with the distortion blend, we'll just swap between the 2 texture samples. And we'll adapt this distortion to be usable for screen UVs. We'll need the grab screen position, and we'll just isolate the X and Y vector. And we'll just subtract the distortion effect we just did with the screen position. So we only need green and red channel. So we'll mask the Z vector. And finally, we just need to multiply that with a really small value to avoid the effect to be too strong. I'll keep it as a constant, but you can set it as a property. And this will be your screen UVs. Alright, so we have all our UVs now. And now to simulate a transparency effect that is distorted, we'll just need a grab screen color. and we'll put the screen UV we just did in the grub screen color UV. So basically it will distort the scene that is being rendered and set it as a color for the mesh. On HDRP, you need to tick on the exposure to avoid that problem. And boom. No, it's working. So I'll just visualize the outline. It will be easier for now. And it's working as intended. Perfect. So now we can move on the actual glitch displacement. And we can start using the combined glitches that we just did before and use them as a vertex offset. So let's just call back our glitch variables, the combined one. And we'll multiply that with a float. That will be a property, and that will be basically our intensity for the displacement. So call that glitch displacement strength. And finally, because we want the glitch to move on the horizontal axis, we'll need to plug this value into a vertex tree, an append node, and only to the x. So only the x will be moving. And let's see. As you can see, it's working as intended, but there is one issue. Because it's moving only on one side, depending on the mesh position, like the x-axis of the mesh, then at some angles it will not work visually. And we'll just see a bit more in depth why it's acting this way. So let's start with vertex position. So that's just to visualize the problem correctly. We'll step it, and we are going to check how the displacement is working. So I'm splitting the mesh in two with a mask, and we'll just move the white part. So it's basically just a debug overview. All right, so as you can see, it's moving on the x-axis depending on the mesh. So it's working at this angle, this camera angle, but let's imagine we are viewing it from top. It's really not the behavior that we want. And that's the same thing for a lot of view, actually. We really want to get the glitches being displaced on the x-axis no matter what camera angle you are using. So in order to do that, we'll just recalculate it a bit. So we'll use a view direction node. You can safe normalize that just to be safe, basically. And we'll do a cross product with just value of 1 in the y-axis. We'll normalize that. And we'll negate that just because it will be the correct direction. And that's basically all that we need. So now we can just plug that in the multiply directly. So it will be influencing also the glitches. And if we connect all of this, you'll see that it will be working. So now, as you can see, it's following the view direction. So it's acting like that on the top because the mask is from bottom to top. But our glitches mask are actually depending on screen view, so it will be okay. All right, so we can remove the debug thing and just plug that into the actual multiply that we just did before. Let's just keep that clean, and if we plug that in the vertex offset and the color in the color, let's see. All right, so it should work at any angles now. Perfect. And top view too, obviously. Perfect. So this is one of the main issues that you can face doing this kind of effect. So it's now fixed. And now we'll move on the actual emissive part, so the refraction and this kind of stuff. So let's start with the accentuation of the offset of the refraction when the glitches appears. And we'll use a scale offset for that. And we'll basically use the exact same thing as we use for the vertex displacement, but instead of displacing vertex, we'll displace a bit more the UV. So same thing, we add a multiply. We bring back the combined glitches. And we'll need to multiply everything and add a float property to deal with the intensity. Then we'll have to add a negate just to fix the direction of it. And lastly, we just need to plug that into the offset. As usual, I'm doing that for my purpose, but you could even do the same thing with an affluence for the scale, for example. And let's also set it as a property. And let's see what happens when we are increasing or decreasing the value. As you can see on the same view, it's basically moving, pushing forward or backward. I mean, on left or right, the image. So this is basically the behavior that we are aiming for. There is already a little offset, but it will allow us to increase that basically. Now we can jump on the emissive part. So that will be the hologram effect basically. And I'll just take this texture for now. That will be our main sampler. So let's call that emissive map. So it will adapt depending on the mesh UV. And since we are using a cube, it will be good for us. This one has to stay in the inspector. So we are not taking it on. We'll handle the scale and offset ourselves in the shader. So I'm just taking the no scale offset checkbox. We'll duplicate that and set them as reference. And basically that will allow us to split the channel RGB, so it will create a bit of chromatic aberration. We'll need to combine our two glitch mask. So let's bring them. We'll add them. This is basically the same as the combined glitches, but without intensity in them. So this is pure black and white. We add them and then we have to saturate that so it's not exceeding 1. And we'll add a multiply with the value. So it will soften a bit the mask. And we'll negate one of the output, just so one is going on the left and the other on the right. We just combine this into a vector 2. So it's only moving the x-axis. And we have our offset EDV. So we can plug this into a texture coordinate node. So obviously the first one will remain at the middle, and only the green and blue channel will be pushed on the side. So let's create a vector 2. So it will be our tiling. All right, so our 3 texture coordinate UV are now set up. So let's align that a bit. So you can already see the mask is being affected by the glitch behavior. And let's set the multiply intensity to 0.075. Let's create a color that will be our main color. So there will be 2 colors, the base one and the glowing part. So let's create 3 layers node now. And the alpha of this layer will be the emissive mask. So it will define where the emissive or the base color is. And instead of plugging the color into each layer, we'll plug each of the channel of the color in each one of the layer. So basically the red is going in the first one, the green in the second, and the blue in the third. So it will handle each channel differently, separately, I mean. All right, and obviously when the mask is white, it will be the glowing part, so we'll need a secondary color. That will be our emissive color. And we'll set it at HDR just to allow really glowing colors. And we'll do the same. So we'll plug each of the channel in the respective one. All right, so basically now we just have to combine this 3 channel into a vector. So it will be a real color now. And some channel will be displaced. So let's do that. So we can use only a vector 3 actually, just because we don't care about the alpha for now. And as you can see, it's working. We can save that into a variable that will be our emissive or emission color. So we can connect that to a color. So let's create a lerp. The transparency that we did with the distortion will be our black value. And the other one will be the emissive. So for now, we don't have a mask for this. So just let's plug that in the color just to see. And we can see it's working. This is exactly what we want. When a glitch happens, it has the chromatic aberration. And now we just need to do a mask to define where is the transparency and where is the color actually. You can create 2 texture samples that will be just references of the mask map that we have already, and we'll be using the green and blue channel this time. So if you remember, one will be the pulse and one will be the little strips. So let's use the fixed screen UVs there. So same thing as we did before. This is actually exactly the same. So we'll be doing a panel and we'll have some properties to control that. So we'll need a vector just to move that in one axis only. So it should be our stripe speed actually. We put a negative value so it's going bottom to top. And we can duplicate that and call that stripe scale. Because just I want to be able to customize that directly in the inspector. And we can plug that in the speed. We'll just need a time node. So let's duplicate that and do the same for the second texture. This one will be the pulse speed. Let's set a different value. It will be a bit slower, obviously. And perfect. So basically, I don't want to touch the scale of the pulse, so I'm not doing a scale and offset for the second one. So we can plug this UVs just to see already what's happening. So this will be our strips, and this will be our pulse. All right, and you can see a bit better with a relay. So this will be the strips. And if you plug that in the color just to see, this will be really looking like an hologram effect. It will be our main opacity, basically. We'll add the pulse after that. So we need to add some properties to control that a bit. So let's start with two float. One will be the overall opacity. So basically it will just scale down or up the wall effect. So we want to claim that at 0 and 1. And this one will be the strips. So it will be basically a subtract between the two. So let's set them all as property. And let's subtract that. And we need to clamp this on 0 at the minimum, just because otherwise, if you put a really high value in the stripe intensity, it will be a problem. And we'll be using the overall opacity as maximum. Just in case we want to add features, it will be a bit cleaner, just because it's more logical that it will never exceed the overall opacity that we set. And we'll remap the output of that, of the green channel, blue channel, sorry, like that. So it goes from 0 to 1 to this new minimum and to a maximum of the overall opacity. And if we plug that in the color, you can see already how it's working. Let's touch a bit the property. So if I'm taking the overall opacity. It's affecting all the shape and increasing the strip intensity will just make it more intense and more visible. Like the hologram effect will be more visible basically. Now we'll work on the second mask. So it will be just remapped. Firstly, if you want to see what the emissive is, let's plug the green color. As you can see, it's just like a pulse effect. And that will be influencing our alpha basically. So we just need two controller for the minimum and the maximum of that. So it will go from 0 to 1 to whatever you want. So one will be the minimum pulse opacity and the other will be the maximum one. And I'll show you what it is doing. Basically, you will be able to really control the pulse intensity. So as you can see, if I increase the minimum, it will obviously be always visible. Otherwise, it will be almost invisible. And we want to do some mask with it, some variable with it, sorry. This one will be the pulse mask. Let's plug that in, and we can do a variable for the other one. That will be the opacity. So I'm separating the pulse mask because we'll use it to boost a bit the emissive when the pulse is going over the emissive part. So we can multiply the two masks. And we'll do the boost effect for the emissive. Oh, we can also connect the lamp first. So now we have our alpha variable, and we'll see if it's working correctly. All right, perfect. So as you can see, the main color is really subtle, but it's tinting a bit the mesh. That's perfectly what we want. And the emissive is actually looking really good for now. And we'll do the boost effect. So there will be two things. Firstly, let's do 3 multiply and 1 float. So that will be a float to control the boost intensity. So let's call the property emissive boost. I'll let that to 1 or 1.5 for the moment. And we need the mask we just did, the pulse mask. So as I'm always explaining, feel free to do whatever you want. You can adapt it to have to get the behavior that you want to. This is just some ideas. And if we multiply everything and connect that back to the alpha, it will be working. And as you can see, now when we boost the emissive, it's working. So it's only affecting the emissive mass, which is perfect. So it's not too visible, and that's what I wanted. And let's set a minimum of 1, just so it never goes to 0. So let's come back in our scene view. Let's try to change a bit the colors. We can hide the outline now. And let's see what it's looking, how it's looking. So you can see a bit more the color tint. So remember that we are splitting the RGB of this color. So if you put a value that hasn't any blue, for example, then the blue couldn't be split. So you can change a bit the shader to adapt that, or you can just be careful to use colors that are using the 3 channels. Alright, so I just cleaned up a bit the shader and I forgot 2 things in my values. So if you want to set them as mine, my glitch spawn speed are set to 3, and the second panel speed of the second UV is using a value of -2. So in my own shader, I added some option and additional features like vertex displacement in another way, and some Fresnel, some different kind of pairs. So as I explained multiple times in the tutorial, just feel free to explore the different behavior that you can have with this base shader. I can show you quickly what I did. The Fresnel, I will advise you to do that. Just I'll show you right now. So as you can see, on different shapes, I'm using a different kind of emissive map that match my mesh, but sometimes a Fresnel can help a lot for the actual border of the mesh. So I'm even using it for the sphere because it's really hard to define the borders. And as you can see, playing with the tile can also be something. So feel free to explore what fits the best your mesh. As you can see, if I set different values, it can be really different. So this is the end of this tutorial. I hope it will help you, and you can also ask me a question or share your custom shader on the comment section, or even your ideas for next shader you would like to see.